CS3491 Artificial Intelligence and Machine Learning Laboratory. So exercise number 1B, implementation of depth first search algorithm. So depth first search is a recursive algorithm which uses backtracking too. So a simple example, here there is a graph. Graph starts with node A and then which starts from node A initially. After that, which entering into node B. Then in depth wise, so search node D. After that, there is no child nodes, so backtrack to B. Then now which found E. Then again a child F. Again there is no child, so backtrack to E. There is no another child, so backtrack to B. There is no another child. No, backtrack to A. There is another child which will be called as C. This is a process of depth first search. So which uses two array, one which is called as visitor, at last one which is termed as output M. So initially we start from a node A. So node A which is added in visited array and then which is placed in the output M. So A is visited first. Then in the next stage, which will be moved to its neighbor of A, which is B and C, initially which will take B, then which call again, so the neighbor of B is D, so D which will be printed, then there is no other child, so backtrack to B, then find the another child of B, that is E, so E which will be printed, then now backtrack, there is no, there is a child called as F for E, so F which will be printed, then which backtrack to E, backtrack to B, backtrack to A, at last which will print C. So this is what a depth first search algorithm works in simple Python program. So starts from the example. Initially it starts from the node 14. So this is a graph. So the graph which will be implemented in Python as a list dictionary. So 14 as a root, then its child 12 and 16. 12 as their root and 11 and 13 are their child. 16 as a root, 17 is their child. 11 is a child, there is no another childs are available. 13 is a child which having child 17. 17, it won't have any child. So this way a graph is implemented in Python. Now, initially the visited array is empty. Visited set is empty. So this is a code. So DFS of visited comma graph node. You can pass the root node as 14 first. Initially you can pass root node of 14. The 14 which will be sent to here for that graph. Then if node is not visited, yes, not visited, 14 is not visited. So initially which print 14. You see here. So initially which pass graph of 14. If the 14 is not visited, so which print 14 and add it in visited array. Again which call its child, there are two childs are available, one is 12, another one is 16. There are two childs are available, one is 12, another one is 16. So for neighbor of 12, 16. Again call the recursively the same function, pass 12 as the root. So 12 which will be passed, again if it's not visited, so 12 which added in array and 12 was printed. Then now the neighbor of 12 is 11, 13. So neighbor of 11, 13. So again which pass 11. So which print 11. Then there is no other child, so which will backtrack. No other child which will backtrack. So 11 was printed. So next backtrack 13. So graph of 13. So 13 was printed. Any child for 13? Yes, 17 is available. So graph of 17. So 17 which is printed. There is no other child than 17. So again backtrack. Then which will print at last 14, 12 by 14 and 16. So 16. So which will print 16. 14, then its child 16. So this is what simple DFS algorithm works in Python. The simple coding as well as their Colab link which is available in the description. use it. Thank you. Thanks for watching. It's a code and its Colab link is also available. Thanks for watching. Thank you.